In the example shown on this slide, we will see how the elimination method can be used to determine that a system of two linear equations has either no solution or has an infinite number of solutions. Let's look at problem number 1. Our first equation is 2y minus 4 equals negative 3x, and our second equation is 6x plus 4y equals 8. Notice that our first equation, 2y minus 4 equals negative 3x, is not written in the standard form of ax plus by equals c that we would prefer for the elimination method. So let's transform it into that correct form. In order to do so, we will need to add 4 to both sides of the equation, and we'll also need to add 3x to both sides of the equation. Now we have the equation 3x plus 2y equals 4. Let's recopy our second equation, which was 6x plus 4y equals 8. And now examining the coefficients of our variables, we see that neither coefficients are opposites. We can obtain opposite coefficients by simply multiplying both sides of the first equation by negative 2. Now let's rewrite the new equation below our second equation. Now we have negative 6x minus 4y equals negative 8. And we can add these two equations together. When we do so, notice that both the x terms and the y terms on the left-hand side will cancel out because they have opposite coefficients. So the left-hand side of this equation is 0. And on the right-hand side, 8 plus negative 8 is also equal to 0. Now remember that if we obtain an equation that is always true, such as this one, that indicates that the original system had two equivalent equations. So this system has an infinite number of solutions. And if we graphed it, we would see that both equations form the same line. Now let's look at problem number 2. Our first equation is 6y equals 4x minus 9. And our second equation is 1/2 x minus 3/4 y equals 1. Again, the first equation is not written in our standard form. Let's add negative 4x on both sides. And now we have the equation negative 4x plus 6y equals negative 9. Our second equation is in standard form, but it does have fractions as coefficients. It might be easier to work with whole numbers as coefficients. So let's clear the fractions from the equation by multiplying both sides of this equation by 4. As we do so, we obtain 2x minus 3y equals 4. Now examining these two equations again, we see that we don't have opposite coefficients for the x terms or for the y terms. But if we simply multiply both sides of that second equation now by 2, we will obtain opposite coefficients. So let's rewrite the second equation. We have 4x minus 6y equals 8. And now let's bring down the first equation, which was negative 4x plus 6y equals negative 9. When we add the equations together, we see that once again, both the x terms and the y terms cancel out, so the left-hand side is 0. And on the right-hand side, we have 8 plus negative 9, which is negative 1. Obviously, 0 equals negative 1 is a false equation. This indicates that the original equations of our system would be parallel lines, and therefore this system has no solution.